we're going to look at a mechanism to facilitate communication among components when working with fragments. Specifically, we're going to look at a way that we can allow information to be sent from a fragment to a parent, in this case, an activity, without the use of view models. And first, let's explain why we want to do this. So, prior to the introduction of view models in Android, there was sort of a best practice or a recommended approach for allowing information to be transmitted from a fragment to its parents, and that would be the only recommended channel for communication because of this goal we have with fragments of keeping coupling low and cohesion high. We did not want to introduce more knowledge than it needed to have about the outside world. So the only thing a fragment does know is that it's attached to a parent. It knows that by default. So we wanted to facilitate communicating from a fragment to its parent, and the way that we would do that is using interfaces. With the introduction of view models, that recommended approach was changed to basically allow a fragment to update a view model and then have anyone who is interested in knowing about that change subscribe to, say, a live data or a flow object, and that's how they would receive that information. The problem, in air quotes, with that approach is that when we think about view model, we and the objects contained within it, generally things like live data or flow objects, we think of them in terms of state information being changed and UI elements subscribing to be notified of that state change so that the UI can stay in sync. And that's perfectly fine, but it, if not ignores, it sort of presumes this notion that all events that occur in an application are reflected, or result in and reflect in state change that the other components are interested in. In other words, it conflates the state change and the event that caused the state change. And if you look back at some topics covering how we use fragments, you will see that this problem was recognized and addressed with different approaches to managing single events, i.e., when an event that causes a state change should result in the UI responding in some way, you did not want the UI to continue to respond if it was recreated, say, through a configuration change, because that event already occurred. But because we were treating the state change as if it was also the event, every time we would resubscribe to a particular live data object or a flow object, we might get the data and then act on it again. So we would find mechanisms to prevent that. Well, with the original approach, the use of interfaces, we actually never had this problem. We still have the original problem of how we make sure that the rest of the application is in state or in sync with the state. But at least we never had this problem of an event being triggered multiple times. And in fact, by moving away from this approach, we've sort of lost this ability to just communicate an event and only an event. So this is something that we can do and still implement. It's just not the practice that is being pushed by the Android documentation, but we're going to look at it today. So let's take a look at what we have here. We have a simple application where we have a fragment and an activity. Inside of our fragment, we are performing what we're referring to as a dice roll, but it's really just the generation of a random number. That's all it is. When this fragment is created, it's told how many sides. It represents a die, and it's told how many sides it has. And there's a button that when we click the button, we generate a random number from 1 up to the number that was provided at instantiation. What we also have is an activity, and in that activity's layout, we have a text view. So the text view is where we would like to display the number that was generated via our dice roll. So we need to communicate the fact that this button was clicked and the information that was generated to the activity. So this absolutely could be done using a view model, but I would like to demonstrate how this can be done using interfaces. So let's start with the fragment. This is where pretty much most of the work is going to be defined. Recall that we have these principles, this idea that a fragment should not know about the outside world. We want as little as possible. We want to keep coupling low and we want to keep cohesion high. That is, everything inside the fragment works well together and nobody knows about any other element if they don't need to know about them. So in order for our fragment to communicate something to the parent, it needs a way to reference it. It needs a way to pass that data. Now, our fragment knows that it's connected to a parent. It knows that it's connected to something, or will be connected to something called a fragment activity, or rather of type fragment activity. So in the case where we've generated a random number, if we wanted to communicate this number to our parent activity, then we could do it in a very sort of hacky way. Keep in mind that whenever we say we want to communicate something, we want to pass a message, that's just a fancy way of saying we want to invoke a function. We want to do a function call. So what I need is for my fragment to call a function in the activity to tell it that a dice roll occurred and here is the result. So if I want my fragment to call a function in my activity, then you might start by saying, well, let's define an activity. Let's define a function. So we'll say function, it's public by default, dice roll, and it needs to take an argument. So that argument would be an int value, well, result or number, whatever, be an int. And the goal of that is to take this dice roll number and use it to display this number. So right now, this is a local property. Because I have a separate function and I want to manipulate it, I cannot have it be a separate, it cannot be local. It has to be an actual top level property. So val display, well, I guess I'll just do late init. And now we can say number display dot text is equal to result dot to string. So that's the goal. So the activity, if you call the dice roll function and you pass a number, it will display the number here. It'll display whatever you pass it. So what I need to do now is have the fragment tell the activity that a roll occurred. Now, this can be done in a few different ways. The first and the hacky way is in my onCreate view, and perhaps a better place to put this would be in onViewCreated, but let's just keep it simple. Every fragment knows it's connected to an activity. It's connected to it directly or indirectly. And as such, every fragment has a reference to activity. Now, activity itself is nullable. It's a fragment, it's a type fragment activity, and it is nullable because at the time we use the activity reference, we may or may not be attached to the activity yet. It depends on which lifecycle function we're using to call this and what the state of the fragment is. If you are sure you're going to be in a state where you can access the activity, you can simply call require activity, which is a non-nullable reference that will return a non-nullable reference to a fragment activity type, which is the activity you're supposedly connected to. And of course, the safe way to do it is just to say activity run scope function, and that has a reference to the activity if it's not null. So that's the safest way. Okay, so what we want to do here is we want to make a reference, we want to make a call to our activity. So activity here is fragment activity. Fragment activity then is the context object, the thing I'm connected to, and I can now try to call the function. Now, I may want to call the function simply by typing the name, because remember, this is the context object, this is the reference, which means I can simply type a function name or a property, and it'll be as if I'm calling it on this object. So the function I defined was called dice roll. So I start to type dice roll, and I notice nothing is coming up. I'm going to verify, double check that, yeah, I have a function called dice roll, but it's not coming up. Now, why is it not coming up? It's not coming up because dice roll is not a function defined for type fragment activity. It's a function that is defined in my specific activity, which is called main activity. So in order for me to invoke this dice roll function, I would need to take my fragment, take my activity, and cast it as an instance of main activity. Now I'm telling the virtual machine that the fragment, the activity that this fragment is connected to is not just any old instance of fragment activity. It is my instance, the one that I created, which is main activity. So now I can call dice roll, and I can pass this random number, which was an integer. So I'm just going to take the first bit and I'll pass it up like that. So now I'm generating the random number and passing it up to, and communicating it up to the top level. So this is the way that I can do this. And if I run my code, it actually works. However, the fact that it works is not enough. So if I click roll, I see that I'm seeing it. But this doesn't solve my problem. I mean, it solves the problem in front of me, but it creates a new problem. And that is, by using this approach, I have increased coupling, meaning I have linked my fragment instance not just to a parent, but to a specific parent. I've linked it to this class called main activity. It means that if I were to try to use this fragment in another class, even if I were to create another activity now called second activity, and I tried to use this fragment in second activity, it wouldn't work. I would have a class cast exception because this would not be main activity, it would be second activity. Even if it had the function defined, the dice roll function, it would still not work. So I can't use it with a second activity, much less another project. Imagine trying to then copy this fragment and use it in another project or include it in a library. It wouldn't work. It can only work with this activity because it references it by name. That's what coupling is. And that's the thing we always want to keep to a minimum when we are working with fragments. So yes, I'm speaking to my parent and I'm calling a function, and that's the only way I have to communicate right now. How can I do this while reducing coupling? Well, this is where interfaces come in. Right now, I'm using a reference to my parent activity by its name. Basically, I'm speaking about my parent based on what it is. Its main activity. And main activity, I know, has this dice roll function. But what I'm going to do here is I'm going to introduce interfaces. And recall that an interface is a way to reference an object not based on what it is, but based on what it does. So an interface can be a contract that I specify, and my expectation in the fragment will be, I don't know who I am connected to. I don't know which activity I'm connected to. However, what I want to know is that the activity I'm connected to, despite whatever it is, despite its name, I want to know that it has implemented a specific interface. And in that interface, I'm going to define all the functionality that I need And therefore, if I can assume or verify that my parent has implemented this interface, then I can safely make these function calls. And because it's an interface, any parent, any activity that implements the interface becomes a candidate to host a dice fragment. I just realized I should have called this die fragment, but anyway. So here's what that looks like. Because the interface is something that is going to be used by the fragment almost exclusively, we're going to define it inside the fragment. This is not a requirement, but it makes sense. This is the cohesion part of low coupling, high cohesion. Separating it into its own class, while possible and everything would still compile and work, I've just created another coupling scenario where one class needs to travel with another class. And again, because the interface is being defined solely for the functionality of the fragment, then it would make sense that it be defined inside the fragment. So I'm going to define an interface called dice roll interface. And in this dice roll interface, I am going to specify all the functionality that any parent that wants to host this fragment needs to implement. In this case, it's just a single function. It's a function called dice roll. And dice roll will take an integer, which we call result. Doesn't matter what we call this here, as long as the type is int. So this is the function that I expect my parent to implement. And then, instead of trying to reference my parent by name, as I'm doing here, what I will do is reference my parent as an instance of dice roll interface. So take the reference to my parent, treat it as a dice roll interface. And because it's a dice roll interface, I should be able to call dice roll. Now this code will crash if my parent did not implement dice roll interface. I can prevent that by saying if this is dice roll interface. So in other words, if it's safe to do that, I check the type and make sure that the parent is in fact an instance of dice roll interface. If that's the case, then I can now safely make this call. So I can do that. And if not, I could throw an exception or whatever. Or degrade gracefully and just don't do anything. So this is the version that I can implement. Now, if I were to run this code, it will not work simply because this check is going to fail. So even though the parent has a function that matches this signature, it's not the same because the type is not the same. It fails. And just to show you, if I did not have this guard and I ran this code, again, even though the parent has the dice roll, the application would crash because I would have a class cast exception. So there we go. The crash occurs. So I'll put my guard back to make sure that the application doesn't crash. And again, if I roll, nothing happens. Now, what I need... Ooh, lots happening there. So what I need in this scenario is to... Let's make sure we're not crashing. Good. Now, what I need in this scenario is to make my activity, and this is the last thing I'll do, make my activity an instance of dice roll interface. And I do that as I do with anything else, with any other interface. I simply say main activity is a dice roll. Now, I'm going to take this code. I'm going to cut this line so I don't have to type it again. I'll make a copy. And I'm going to delete this function just to show you how it all comes together. So when I then say that my activity is an instance of, and in this case, the name of the interface is dice roll fragment dot dice roll interface. And if I were to just type dice roll interface, the IDE would help me out. So if I just say dice roll interface and press enter, it fills it out fully for me. I'm now being told something is wrong. The thing that's wrong, of course, is that I don't have all the functionality that this specific interface defines. And as we know about interfaces, when you've specified that you're implementing an interface, your two choices are either implement all the functionality or declare your class as abstract, incomplete, basically, and therefore it cannot be instantiated. So here I'm going to specify that I want to implement my members. In this case, it's just a single function dice roll. I enter, and I get the same function back, except now I have this override piece letting me know that I'm overriding functionality that is coming either from a class that I'm extending or an interface that I'm implementing. And in this case, it's an interface that I'm implementing. And now I'll put my code here. And running my program, I get my dice roll. So this is the basics of using interfaces to facilitate communication from a fragment to an activity. We know that if I want to communicate from the activity to the fragment, that's simply just calling a function defined for the fragment. That part is straightforward. But being able to speak to an activity from a fragment, in the absence of view models, we are dealing mainly with state. The mechanism to do it is this: an interface where you'll see that in my fragment, I have no references explicitly to the activity. That means I can now use this fragment in any other activity, in any other project, and as long as the activity that is going to implement or that is going to host this fragment implements this interface, it will work. All right, so that is how we create a communication channel from a fragment to an activity using interfaces.